Many of you have likely heard someone say that if the sun blows up, we wouldn't know about it for another 8 minutes. It would actually take 8 minutes and 20 seconds for the light from the sun to reach us, but that's beside the point. This is just one of the seemingly strange and bizarre things that can happen as we approach the speed of light. This relates to something called time dilation, and there are two different types, the first of which being relative velocity time dilation. This is a concept within Einstein's special theory of relativity. This refers to how the faster an object moves relative to an observer, the slower time appears to pass for the moving object. Essentially, when an observer moves at a significant velocity compared to that clock, time appears to pass slower for the moving observer. This effect becomes more noticeable as the observer approaches the speed of light. The second type is gravitational time dilation. This time dilation, as described in Einstein's general theory of relativity, is a result of being at different distances from a gravitational mass. The closer you are to a gravitational mass, the slower your clock appears to tick to an observer that is farther from the mass. So if you were an observer watching a spaceship near a black hole, they would see the spaceship slow to a crawl, while the people within the spaceship wouldn't know anything is happening. Now you might be thinking, wow, that is a crazy theory. But it's not just a theory, it is an actual phenomenon. We are all subject to time dilation right now. It's just at such a minimal scale that it's not noticeable. But there are ways that time dilation does impact our society. One example is GPS satellites. The satellites orbit far away enough from Earth that they are measurably different, with their clocks ticking faster than ours on Earth. Due to time dilation, they have been programmed to compensate for this time difference. Another example would be super precise clocks on airplanes. Clocks on airplanes would tick at a different rate from those on the ground. This is a result of relative velocity time dilation. Due to the high velocity of the plane, their clocks would run at a very small fraction of a second slower than those on the ground. Time dilation has also led to some very interesting paradoxes, such as the twins paradox. Consider two twins, one living near sea level and another living at a very high elevation. The twin at sea level experiences a greater gravitational pull than the high elevation twin, meaning that their clock would tick at a slower rate relative to the twin at the higher altitude. So although they were born at the same time, their relative ages would change ever so slightly. So although the effects of time dilation may seem minuscule, it is an interesting phenomenon that opens a gateway of possibilities.